Hello everyone. Hello. Hi everyone. How are you all? कैसे हैं सब लोग? Guys, let me just finalize the setup here. Okay. If you can see me, if you can hear me, just write yo in the chat box, everyone. Okay. I can hear myself. Okay, guys. How are you all, people? If you can see me, if you can hear me, just write yo in the chat box. Come on. 11th moving to 12th, Janta. Hello everyone. Hello. Who all are here? कौन है class में? Who all are here? Hey guys, if you can see me, if you can hear me, just shout out, let me know. Okay. Yep. Awesome. Yes, it's buffering. It's buffering for me also. I'm actually trying to understand that only. Okay. Let's see. Some internet issues during this lockdown. Let's see if things are working fine. Yep. Looks like now things are fine. So guys, now one more time, if you can hear me, if you can see me, just write you in the chat box. Just the final drill so that if this process is smooth, we can go forward from here. It's visible now? Yeah? Better? Awesome? Cool. So welcome guys, welcome to Vedantu's JEE channel and people who are moving to 12th standard from 11th standard. This is an exclusive series for just only for you people. Okay? Yep, this is keeping and targeting JEE 2021. So all the students who are targeting JEE 2021, just write you in the chat box because this series is exclusively for you people and that is what we have started this week. This is the session number 2. You know that in 11th standard you studied mechanics, you studied thermodynamics. When now you will be moving to 12th standard, you will be studying electrodynamics, you will be studying optics, you will be studying modern physics. So this is the start of electrodynamics. In electrodynamics, we are going to study electrostatics, where we'll be speaking about everything related to charge. We'll be speaking about magnetism, where we'll be speaking about things related to the magnetic effect. We'll speak about how the electricity is generated. We'll speak about alternating current in future. We'll speak about after that light as wave, as particle, and its optical nature. Okay. And finally, when we'll be wrapping up our 12th standard syllabus, which I'm expecting it to happen before Diwali this year. Yeah. So when that will happen, we'll be covering modern physics. Okay. So stay tuned to this channel, guys. And this is me, your Suri Sir. By the way, for people who do not know me, this is me, your Suri Sir, also known as Mogambo. Yes. Why am I called Mogambo? Is because when you will crack the examination of JEE next year, yes, you will. Mogambo Khush Hoga. Okay, guys? Awesome. Okay. Oh, am I giving any surprise? I was expecting a surprise. What is surprise? Darshan is asking. Darshan, can you tell me the surprise? I don't know what surprise you're talking about. Yes, there is a surprise coming tomorrow at 5 o'clock. Stay tuned to the channel. You will be meeting your very own, very favorite Paul sir. Okay. So, what is the surprise? Is something that obviously he is going to share with all of you, with us as well. Okay. So, guys, let's go forward. For people who are not aware about the timetable, let me tell you how the schedule is working on our channel. Okay. So, this is your very own Harsh sir. Harsh sir is the one who is teaching you chemistry. He is going to tell you all the amazing ways of learning chemistry. This is Arvind sir. I'm sure you guys have met both of them. This is me. Yes, this is me, your Suri sir. Remember the days. Take a screenshot if you want. Okay. So we are going to meet on every Wednesday and Saturday like this at 9 o'clock, and every Monday at 8 p.m. we'll have our MCQ session. Okay, guys. So remember, Harsh sir for chemistry, Arvind sir for mathematics, and me for physics. Okay, guys. So we'll keep on meeting in this way every week, and we'll cover the entire 12th standard syllabus with respect to JEE examination. Okay, guys. Also, one very important thing, if you want, you know that on platform of YouTube we try to deliver the best possible education to each and everyone. But if you want your doubts to be catered along with the studies which you are doing, if you want to appear for test, online test with respect to JEE examination, and if you want to take the advantage of everything that Vedantu is doing right now, then all you have to do is follow this link and come to our platform, guys. Right now the enrollments are free. Please note that enrollments are free, and this link is available in the description of this video. You can come to our platform. Okay, obviously you can see that I'm not able to take all the doubts here on YouTube, and you are just meeting me, Harsh sir and Arvind sir over here. With me, with us, we have an amazing awesome team of 45 plus teachers who are going to just coach students who are moving from 11th to 12th standard. Okay, guys. So if you want, you can come to our platform as well. Okay, you know that the registrations are free. Come online with us and learn online. You know that your JEE examination has become online long way back. You will appear for online examination. So if you are only studying in a paper and pen mode, that's not sufficient. You know that. Okay. I think enough said. You understand this. Okay. And for people who are here on the channel for the first time, people, come on, take a note that this channel is a very important blessing in disguise right now for you. You know that during this lockdown you cannot go out, but still your time is valuable. You have to appear for JEE examination next year. So if you want your studies to continue, the only solution for that is to subscribe to our channel. And as I shared the schedule with all of you, as per that schedule, come to the classes every day 9 o'clock and 8 o'clock. Remember the schedule, 9 o'clock and 8 o'clock every day. You have to come to the channel, check out what's happening, and trust me, you will get the benefit. Okay? Yes, guys, I remember your names. I'm not reading the chat for a while, but don't worry. I do read the comments more. Okay? So if you want to be noticed, mention your names and your comments in the comment section after the video is done. Okay, so guys, what's the session plan for today? By the way, this is your session number 2. This is session 2 of electrostatics. First session we studied Coulomb's law, and now we are taking it forward. Today's session is going to be about something called as electrical field. In 11th standard last year you studied gravitational field, and very much with that it's going to resonate. This is electric field that we are going to speak about. We'll speak about how to visualize electric field. We'll speak about properties of electric field lines, and yes, we'll do some basic problems as well. Okay, guys. Thank you, Mukesh Meshram. Thank you so much. So, guys, yeah, I'm sure that you all are ready. So, guys, let's speak about electric field of a point charge. Okay. I can see myself getting hanged on the chat. There is some lag, I think. It's buffering. Yes, 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 yes. Okay, much better. Yep. Cool, guys. So let's start. This is a electric field of a point charge that we want to understand. So first of all, when we speak about the electric field, let's try to visualize what exactly electric field is going to be. So if I talk about a charge, say capital Q, okay? Just a minute, guys. I guess it's buffering. Is it fine now? Guys, can you see me now? Can you see me properly? Am I audible? Can you write that in the chat box, everyone? Awesome. Great. Thank you for the feedback, everyone. Visible now, right? Awesome. Great, 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 great. Fine, fine, fine. So, guys, let's speak about the electric field of a point charge. Okay, and for that, let's start this understanding. Let's assume that there is a charge whose magnitude is plus q. Okay, start visualizing this. Okay, along with it. So there is a positive charge plus q. It could be negative also. Right now we are speaking for a positive charge, and we are interested in talking about its electric field at a point P. Okay. So before we even understand what exactly electric field is, what we studied previously is that if there is a charge plus Q and at a distance from it, say at a distance R at a point P, say there is another charge at this distance r, another charge small q is placed in the vicinity of this charge. Okay, अगर हिंदी में समझाऊं, प्लस क्यू जो चार्ज है उससे r डिस्टेंस पे एक स्मॉल q चार्ज हमने रखा हुआ है. So last time we understood how we write the force acting between acting on this q charge, small q charge पे there will be a force which will be acting, and that too it is going to be a repulsive charge. Okay, guys, you know that that circle that you see, it's actually not a circle, it's basically a spherical zone. इस spherical zone में small q charge, wherever you are going to place it, it's going to experience the same capital F force whose magnitude is given by this. Its magnitude is given by K capital Q small q by r square. This is something that we learned previously, and that is basically your Coulomb's law. Okay, guys. Now, the region that you see around capital Q charge, the circular section which is visible right now, which is actually a spherical region, is basically what we are trying to define as the electric field, which we are saying that it's an invisible region around this charge where small q charge, if enters, it will start experiencing a force. Means what? Just think of, an invisible region, okay? And in that region, small q charge has entered, and this small q charge is being pushed away by the capital Q charge, and the force by which it has been pushed away is what you see right now written on the screen for all of you. Okay, guys, let me just change the color so that we can see what I'm trying to mention here. Okay, so this is that force. Okay, so how we are defining, we are going to define this electrical field. Electric field at point P, let me just read this out, is defined as the electric force experienced by unit positive charge placed at that point. In other words, it's the force per unit charge. So what you have calculated already is capital F. If I want to find out the electric field of this charge, capital Q का electric field मैं पता लगाना चाहता हूँ, so what I'm going to do, I'm going to divide this force which is experienced by small q charge by the value of the charge itself, so that I can find out the electric field of capital Q. What we are saying, electric field is basically the force which this charge is applying on small q charge divided by the magnitude of small q charge, something like this. Force experienced per unit charge, right? So what you see here in this small q is being taken into denominator, and the expression looks like K capital Q by R square. Let me just tell you that the expression that we have written, that can be visualized in another way. If I replace this small q charge by a unit charge, means what? Just imagine, in the close vicinity of capital Q, instead of putting a small q charge, let me put a 1 coulomb charge. How will I write the force which is acting between these two charges then? The force acting between these two charges will be what? 1 upon 4 pi epsilon naught capital Q into 1 divided by r square. That's how I will write the force, right? That means what? This is the force which we are defining as the electric field. Means what? If you look at this expression, I say that capital F and capital E will become same when the small q value becomes 1. And that is what we are defining as the electrical field. So in very simple words, if I want to put this, very simply, electrical field and its strength is basically nothing but electrical force which is applied by this particular charge. Capital Q charge is applying that force on a unit charge. So the unit charge is going to experience a certain amount of force which will be defined as the electric field of capital Q charge. Okay, guys, let's try to visualize this electric field now. I hope the formula is clear. It is force per unit charge. For a point charge, it is kq by r square. Okay. Now, if I want to visualize the electric field direction for a positive charge, so let's try to imagine that if I bring a test charge. What is a test charge, guys? Remember, what is a test charge? Test charge is going to be a small plus q charge. A small charge plus q charge. Okay. And what we are going to do? We are going to bring it in the close vicinity of this charge. Can I say that if my main charge is positive and my test charge is also positive, will they be attracted, or will they attract each other, or will they repel each other? The small q charge will be attracted or will be repelled? Can you tell me in the chat box? Can you guys tell me? If I bring a small q positive charge nearby this capital positive q charge, will the small q charge be attracted or repelled? Will it be attracted or repelled? Come on guys, quick. It will be repelled, right? So that is how the direction of the force which will be experienced by small q charge is represented in the diagram. What you see here, that small q charge is being pushed away by the capital Q charge. So because of that, small q charge, wherever you place, it will be taken away like this. Yes or no? Wherever you will place it. If you will place it here, it will be taken here. If you place it here, it will be taken in the direction accordingly away from the capital Q charge. So we say that for a positive charge, this center charge is a positive charge, the direction of electric field is going away from the charge. Means what? The direction of electric field is nothing but the direction in which the test charge moves with respect to the charge whose electric field we are testing. जिस चार्ज की इलेक्ट्रिक फील्ड को हम टेस्ट कर रहे हैं विच इज बेसिकली कैपिटल क्यू, इससे पॉजिटिव टेस्ट चार्ज किस तरह से मूव करने वाला है. इज इट गोइंग टू बी अट्रैक्टेड, इज इट गोइंग टू बी रिपेल्ड, इज इट मूविंग अवे, इज इट मूविंग टुवर्ड्स द चार्ज, is basically what defines the direction of electric field. Okay, so similarly let's speak about the direction of a negative charge electric field. So now this is a negative charge and I'm going to bring a positive test charge nearby it. I'm bringing it nearby it. What will happen? The test charge will be attracted. The test charge will be attracted towards this charge. Yes or no? That is why the direction of electric field for a negative charge will always be towards the negative charge. Are we clear with that, guys? I hope things are clear for all of you. For a positive charge, the electric field lines will always go away from the charge like this in all possible direction. And for a negative charge, the electric field lines will terminate on the negative charge from all possible direction. Okay, these are the directions of electric field. Now, what if you have the electrical field lines for positive and negative charge placed together? So what is happening here? You see that a positive and a negative charge are placed together. So now the electric field lines will appear in this manner, which tells you what? That positive charge has electric field lines going away from it and negative charge has electric field lines coming towards it. How can you also visualize it? Think of a test charge being placed close to positive charge. So obviously it will be thrown away. And the path that will be followed by the positive the test charge, is basically all these lines on different path, which is followed by the positive test charge, which is what is being shown here. Okay. So people, let's go through the different properties of the electrical field lines. Okay, first of all, the electrical field lines are the lines that you see here. Electric field lines of force or field will always start from a positive charge and will always terminate at a negative charge. Remember that. Okay. Secondly, if I draw a tangent on any of the lines of these electric fields, then the tangent drawn on any point will give me the direction of electric field. Say if I choose this point and I draw a tangent like this. So this gives me the direction of electric field at this point P. Say I choose another point. Say I choose the point here. So if I draw a tangent here, let's call this point as S. Then this is the direction of electric field at S. Okay. If I choose a point, say somewhere over here, then this is the direction of the tangent. Let's call this point as R. This is the electric field at R. So at any point, if you draw a tangent, that tangent gives you the direction of electric field at that given point. Okay. Next one, no two electrical field lines will ever intersect. Why will the electric field lines not intersect with each other? Imagine the two lines are intersecting like this. Now at this point, if I draw a tangent, I will have two possibilities of drawing a tangent, which tells us that there will be two directions of electric field. And that is not possible for a vector quantity. So that's why two electrical field lines will never intersect with each other. Okay. Next one, the lines of force are crowded in the region of large intensity and further apart in the region of weak field. Okay, means what? What you see here, that this zone has more number of field lines. What you see here, this zone has more number of field lines. While if I draw the same area here, you see that there are 4 or 5 electrical field lines in the same area. Let's say this area is A and this area is also A. In the same area, if I was at this point then the area has 4 or 5 electrical field lines. And if I have the area here, let's call this area as to be present in a region, say that is L, and this is M. So I say that the number of field lines at region L are more in comparison to the number of field lines in the same area at region M. So I can say that more be the number of field lines in a given area, more is the strength of electric field over there. Means what? Electric field at L is greater than electric field at M. That's what this point means. Okay. Next one. Electrical lines of force do not form a closed loop. Remember, electric field lines will never form a closed loop. That's a point that I want you to remember. And next one, it says that, oh yeah, that was the last point for us. Okay, so remember this point, that electrical field lines, as you can see it in the diagram. Yeah, let me just give you the picture again. Yep, so electrical field lines not forming a loop. They are starting from positive charge, ending at negative charge. Okay. Now, time to solve few questions, people. Okay, we'll be solving a few questions today. This is our very first question. An electron enters an electrical field with its velocity in the direction of the electrical lines of force. Okay, so what you see here, that I have an electron given to us, and there is an electric field which is, say, moving in a given direction. Say this is the direction of electric field. Okay, and I have an electron which is also moving in this direction only. Question asking us what will happen to the electron. First of all, remember, electrical lines always start from a positive charge and will go towards a negative charge. So if I speak about this electric field, maybe a positive charge is present here. Whose electrical field lines are we talking about? Okay, and from this positive charge, there is this electron which is being thrown away. You can look at this question as a positive charge and an electron which is being thrown away from the positive charge. So what do you think will happen to the electron? What will happen to this negative charge? It will be attracted by the positive charge, which means what? Even if it is trying to move away from the positive charge, it will be retarded, it will be slowed down. Okay, so that means what? If we look at the options, what do you guys say? You guys say that it is going to follow the parabola path. No guys, it's not going to follow a parabolic path, rather its velocity is going to decrease. Getting my point? It's like, let's consider this as earth and let's consider this as mass. So if you throw any mass away from the earth is going to slow it down and is going to pull it back. So it's going to reduce the velocity of the electron. Okay guys? Yes. Very good. Next one, people. Now this question says that a charged particle of mass m, charge q, is released from rest. Okay. So a charged particle of mass m and charge q is released from rest in an electric field of constant magnitude E. So the kinetic energy of the particle after time t will be how much? First of all, इस क्वेश्चन को सॉल्व करने के लिए we need the concept from work energy bar. I say this n number of time that whatever you have learned in mechanics in 11th standard, it's very super duper important to keep all the concepts in your mind. Okay, you know that there we studied that the work done by a force is going to be the change in kinetic energy. Okay, so here if we speak about the work done, that should be equal to the change in kinetic energy here. Okay, so what is given to us, that the particle is starting from rest and a constant electric field is making the charge move. So if I talk about work done is going to be force into the displacement, and that is going to be equal to the change in kinetic energy. So the question is asking us to find out the kinetic energy of the particle after time t. So for that guys, either I need to calculate the force, or I also need to calculate the amount of displacement that is covered by the charged particle. Yes or no? I can also do one thing if I want to calculate the work done. You know that the initial kinetic energy of the body is going to be 0 and final kinetic energy is going to be half mv square, and putting the initial as 0. So we need the kinetic energy of the particle. So instead of finding force and then displacement, I am choosing the path of calculating half mv square. If you want, you can try this method also by yourself. I'm trying to find out half mv square. Initial kinetic energy 0 because the particle is starting from rest. Okay. Okay. Okay, guys. So let's find out the acceleration first. Acceleration is going to be force upon mass. Force is Q into E. We know that. The electric field is force per unit charge. So the force is Q into E divided by mass. Okay. And if I find out velocity, it is force is constant. So acceleration is also constant. So the velocity is going to be U plus AT. Initial velocity is 0. Acceleration is Q E by M into T is becoming the velocity. Acceleration is QE by m. Now guys, I'll put this value of velocity over here to find out the value of kinetic energy finally. Okay. So final kinetic energy, which is half mv square, becomes q square e square t square by m square. So this m gets cancelled with m, and finally my answer comes out to be q square e square t square by 2m. Do we have an option like that? Yes, looks like option B is our correct answer. Okay, Drashi, I'm not ignoring anybody. Okay, I'm not ignoring anybody. Okay, okay. Next one, guys. A particle of mass m charge q is placed at rest in a uniform electric field and then it is released. So the kinetic energy attained by the particle after moving a distance y. This time after traveling a distance y. In the previous question, after traveling for a time t. So this time we know that the particle will experience a force which is given as QE, and it is going to cover a displacement that is y, right? That is given in the question. So the kinetic energy attained by the particle, kinetic energy final minus kinetic energy initial, is going to be the work done. Yeah. So what you see here, guys, the initial kinetic energy is 0 because it is starting from rest. Final kinetic energy is going to be work done, which is force into displacement. So that is QE into Y. Very simple. Yes, I hope you guys are getting this. Thank you, Kumar. Thank you so much. Okay, so our answer is option C. Okay, guys. Good. Very nice. Now, the next question. So, this question says that there is a proton, a deuteron, and an alpha particle, and all three are kept in the same electric field. So we are to find out the acceleration of them. So let's try to find that. But before that, let me tell you what is the gap, what is the difference between a proton and a deuteron and an alpha particle with respect to their mass and their charge. So a proton has mass m, a deuteron has mass 2m, and an alpha particle has mass 4m. I'm sure you are aware about that. Okay. Proton is 1h1, deuteron is 1h2, and alpha particle is 2h4, 2he4. Okay. So proton has a charge E. Deuteron also has same charge E. Electrons are same. It's only the mass number which is different, and the value of charge of alpha is 2 times of E. Okay, guys. Now, if I'm interested in calculating the acceleration, for that I can say it is going to be QE by M. Okay. So I'll do one thing. I'll just write it same for all of them. Okay. Okay, people. So what I'm going to do now, say I'm going to write the value of force acting on them. So force acting here in the same electric field, F is equal to QE. So when I write that, it is going to be E into E. This is also E into E, but this force is 2 into capital E, charge multiplied by the electric field. So now if I want to find out the acceleration, acceleration is force upon mass. We know this from our understanding of Newton's laws of motion. So this becomes what? E by M. The mass is M. On the other hand, for deuteron, it is same force but double mass. And for alpha particle, the force is double, that is 2e into capital E, divided by 4 times the mass. So 2 cancels this 4 2 times. So this comes out to be E by 2m. Okay, means what? You can see that for deuteron and for alpha particle, the value of acceleration is same. Yes or no? So acceleration for deuteron is equal to acceleration for alpha particle. Let's see the options. Proton and deuteron will have same acceleration. No. Deuteron and alpha particle have same acceleration. Looks like right. Alpha particle will have maximum acceleration. Uh, no, it is actually not maximum. Maximum is of proton. So this option is also not correct. Proton will have the minimum acceleration. That is also not correct. It has rather maximum acceleration. Okay. So for people who are not able to understand what is proton, proton is basically 1h1. Deuteron is 1h2. So the number of neutrons are more. So nucleons are double, but the electrons are same as proton. And alpha particle is 2he4. Okay, guys. Cool. Next one. A tiny 0.5 gram ball carries a charge of magnitude 10 microcoulomb. It is suspended by a thread in a downward electric field. Question looks like is getting into laws of motion. And the electric field is downward 300 Newton per coulomb. If the charge on the ball is positive, then the tension in the string will be how much? So guys, there is this ball which is hanging. Obviously, the tension force will be acting upward on it. Also, mg is acting downward. Now only force that we need to understand the direction of is the electrical force. We know that the force magnitude is going to be QE. Also, the direction of electric field is downward and there is a positive charge on the ball. So if this is the direction of electric field, that simply means this electric field is being created by a positive charge. ऐसा मान सकते हैं. You can assume a negative charge below also, because electric field, if it has a direction downward, then it has to be taken somehow like a electric field generated by a positive charge going away from the charge. Okay, if you would have taken a negative charge here, then also the direction of electric field would have been same, right? So either you assume there is a positive charge creating the electric field or a negative charge creating the electric field. Either way, this positive charge is going to experience a force downward. Why? Because it is repelled by positive charge or it can be attracted by the negative charge. All I'm trying to say that downward there will be another force acting on this ball, which is basically QE. Okay, and question wants us to find out the value of the tension. So tension, as you can see it in the diagram, is mg plus QE. So guys, mass of the ball is 0.5 gram. That means zero point 0.5 into 10 to the power minus 3. G value is 10 plus QE. Just let me create the space for the separate part here. Yeah, and charge on the ball is 10 microcoulomb, so 10 to the power minus 6 has to be multiplied, and electric field is 300 Newton per coulomb. So what do I have here? This becomes 5 into 10 to the power minus 3, and this becomes 3 into, this will be plus sign, 3 into 10 to the power minus 3, which means 5 plus 3 into 10 to the power minus 3. Have you guys got the answer? Yeah, the correct answer is 8 into 10 to the power minus 3 Newton. That's basically option B. Yes, yes. Drashi, answer is B. Yes, Hara. Very nice. Okay, Drashi. Okay. Next one, guys, a good question. 3-point charges, each of minus q, are placed at the corners of an equilateral triangle. The magnitude of electric field at the center will be. How much is going to be the electric field here if I have a negative charge here, a negative charge here, and a negative charge here? Can you guys tell me the answer of this? If it is an equilateral triangle, by the way, you should know that this negative charge will have its electric field towards the charge. This charge will also have its electric field towards the charge itself, and similarly this is the third electric field. So these are the three electric fields that you see, and all are symmetric as well as of equal magnitude, right? Now if I tell you Okay, people have already started responding. Yes, the answer is going to be 0. Let's see how. So this is the angle 60 degree. That means this half angle is 30 degree. This half angle is also 30 degree. So this remaining angle is 120 degree. Yes or no? And we know that for two vectors which are inclined at 120 degree, when you have two vectors which are of equal magnitude and are inclined at 120 degree, their resultant is also of the same magnitude, and that too at angle bisector. That means what? Their resultant will also be E. So these two are basically resulting in E, which is opposite to this E. So this E and this E will simply cancel out each other. Okay, that means what? The resultant of all the vectors eventually comes out to be what? It comes out to be 0. Three vectors which are inclined at 120 degree, guys, ऐसे भी सोच सकते हैं. Three vectors which are inclined at 120 degree are always going to cancel out each other if they are of equal magnitude. Okay. नहीं किथारू cos 120 का वैल्यू -1 नहीं होता है. Cos 120 degree is minus half. Okay. Not maybe, it is. Answer is 0. Okay, guys. Okay, guys. Next one. Two unlike charges of same magnitude Q are placed at a distance d. The intensity of electric field at the midpoint of the line joining them will be how much? Can you guys tell me the answer of this? This is capital Q. This is capital Q. Okay. Can you guys tell me the intensity of electric field at a line joining? One is plus Q, other is minus Q. They are unlike charges. Okay. We are interested in finding the electric field at this point, which is d by 2 and d by 2. Don't tell me it is 0. Okay. Answer is not 0. So at this point, what will happen? This charge, let's say this is A and this is B. Both will obviously have the same value of electric field in terms of magnitude. So the electric field because of A will be here, and due to B also in the same direction. So electric field of A and B will be in the same direction, and I can say that the net electric field will be EA plus EB. But EA and EB will be same in magnitude. How? You can see that EA equal to EB equal to K Q1 Q2 by R square. R is D by 2 ka square. So what do I have? I have 4 KQ square by D square as the value of electric field. Let's see if it is visible to all of you or not. I hope it is visible. Yep, it's visible. Okay. So you can see that the net electric field is 2 times the electric field of A or 2 times the electric field of B. So that means the answer is 8 KQ. My bad, guys, one mistake I made here. I wrote the force instead of writing the electric field. I'll just make the corrections there. Okay. One of the charge only. Okay. KQ by D square. I hope you understood that. Okay. So K 8 times KQ by D square is the answer, which simply means what? The answer is option B. Yes, Drashi, I have spoken your name for n number of times now. Okay. Yes, Sukanya, I'm taking everyone's name, don't worry. Okay, people. Now this question, 2-point charges 8 and -2 are located at x equal to 0 and x equal to L. So there is this charge which is 8Q, and there is this charge which is -2Q. This is at x equal to 0, and this is at a distance L. Okay, and the question is asking us to find out the location of the point from this charge on x-axis at which the net electric field due to these two charges will become 0. So first of all, electric field formula, as we all know, electric field is KQ by R square. So closer be the point, the more be the electric field. And you can see that this charge has more magnitude, this charge has weak magnitude. So certainly that point will be closer to this charge. So if we look at a point in between, 8q charge has electric field to the right side and negative charge also has electric field to the right side. So there is no possibility of having zero electric field on this side. On the other hand, that electric field has to be, that point will be zero, that point will have electric field zero, but that point has to be closer to the charge with lesser magnitude. Yes or no? Hmm? Usually, if I'll try to relate it with the same kind of problem that we used to solve in gravitation, we used to find the null point where the gravitational field due to moon and earth becomes zero. So I hope you remember that point used to be closer to moon. So you can see that this is like earth and this is moon, but only that because this is negative charge. So that's why the electric field will become zero somewhere here. If I call this point as A and this point as B, this is the direction of electric field due to A and this is the direction of electric field due to B at this point. Okay. So if I say that at P, electric field due to A is equal to electric field due to P, first of all, I am going to choose the point to be located at a distance x from here. So from A, the distance is L plus x. We are interested in finding the value of L plus x. So electric field because of A is k q by L plus x square, and due to B it is k 2q, only writing the magnitude, that's why not writing minus. Remember that I'm only equating the magnitude, their directions are opposite. Okay, and x square. Okay, so k cancel, 2q will cancel it 4 times. So overall, rearranging, 4x square will give me L plus x ka square. Taking the square root, 2x will be equal to L plus x. Okay, that gives me x equal to, what does it give me, guys? It gives me x equal to L, and the answer to this question is L plus x. That value comes out to be 2L. That means, guys, correct answer is option C. Yes, everyone. Answer is option C. Very nice. Okay, guys, just a general hack. When you are facing lag, close the video and restart the video in general. In general at YouTube, which is whenever you are watching a live session, close the window and again restart the same window. That means just close that session that you are watching and click on that thumbnail. The point where you will be taken to is the live session again without any lag. Okay, guys. Now, this one is a homework question for all of you, apart from the assignment, which is also there in the description. Please note down the question, or you can take a screenshot, or you don't worry, there will be a session PDF available in the description. Okay. So again, this question says that there is a positive Q charge minus 2Q charge, which are placed at a distance, say D. If the electric field at a location of Q is E, and the electric field at the location of minus 2Q is going to be how much is to be found. Okay. So there are two charges. This is Q, this is minus 2Q. Here the electric field is E. We have to find out how much is the electric field here. Okay, you have your options. Okay, so guys, if you are still not connected with us, let me tell you that joining our Vedantu's Telegram group can be very beneficial for you, because that is where we post the assignment, not just the one which is available in the description. More assignments are shared there. Notes are also shared over there with students, and most importantly, you get to know what is going to happen on our channel on that given day. So if you want to join our Vedantu JEE channel, just follow the description of this video. In the description, you will find this link, and you will also find the assignment. Okay, guys. Also, the link of Telegram group is there. Cool, guys. So do come, and you will be getting rewards. You will be getting the benefit out of joining the Telegram group as well. Okay, guys. So I hope you are enjoying the session with me, and yes, if you are moving from 11th to 12th standard, I know a lot of students in the live sessions are already the students who are going to appear for JEE now, so they know the things already. So if you are a student who's moving from 11th to 12th standard, don't feel disheartened. Things are new for you, so it's okay if you're not able to solve questions in the very first go. do watch the video once again, and then you'll be able to understand things and do solve the assignment questions. And more questions if you want, you come to the Telegram group as I told you. Cool guys. So if you enjoyed studying with me today, like that, you hit that like button over there, like this video, and do share it with your friends. And if you have not subscribed to the channel yet, do subscribe so that you are not missing out on any of the sessions that we are taking, any motivational session, or in general the updates. Okay, so guys, with that note, I'll take your leave. Keep on studying, keep on enjoying, and most importantly, in this difficult time, stay safe. Take care, guys. Bye bye.